Number 3 on the Unit 4 review is probably one of my favorite problems because it should be pretty quick and simple. I gave you in this problem the integral from 2 to 5. I told you it was 6, and the integral from 4 to 5 is 14. So I just want you to use that information to find these other things. And then the last one kind of goes back to this, that a capital F of x really just means the integral of the function. Okay, so we'll talk about that one on the last one. All right, so the first one, this is just a rule that you had to kind of memorize. So if you have an integral from 5 back to 5 again, that means you didn't go anywhere. So I'm finding the area. When I find an area, I'm talking about on these intervals, right? And this one was going from 1, 2, 3, 4, 5 to 5. That means I didn't go anywhere. So that means my area is always going to be 0 in that case. The second one, this is backwards, so you have to kind of pay attention to how these are numbered. This is saying I'm going from 5 back to 4. So remember, you always start at the bottom and go to the top one. Well, if I'm going from 5 backwards to 4, the easiest way to fix that is to say that's the same thing as the negative 4 to 5. So you can switch them, but you got to make it negative. And it's still of that same function. Okay, so that means it's negative, and then find that interval from 4 to 5. Find out what that integral was. I told you from 4 to 5 it was 14. So that means this one is negative 14. Okay, this one is saying I want to know what the integral from 2 to 4 is. Well, if you look at what I gave you from 2 to 5. And then I gave you from 4 to 5. So I gave you from 2, so here's 1, 2, 3, 4, 5. I gave you from here to here, that area. And then I also gave you from 4 to 5, this area. So if I want to know what is it from 2 to 4, which is from here to here, what I could do is take the whole thing and then subtract this away, and then I would have this left, right? So this is the same thing as me saying the integral of 2 all the way up to 5 of f of x minus from 4 to 5. Okay, well, I gave you both of those. So the integral from 2 to 5 was 6, and I'm going to subtract away that area from 4 to 5, which was 14. So this one ends up negative 8, which seems kind of weird, but that just means I had an area that was under the x-axis, and that's okay. Okay, part D. This one is saying I want to know what the integral from 2 to 5 is, except I put a 3 in here. So I have 3 times whatever the function is. That just means you're going to take 3 times whatever this integral from 2 to 5 is, which again, if I go back up here, my integral from 2 to 5 was 6. So 3 times 6 is 18. Okay, and then the last one is actually on the next page, if I can find it. There it is. I'm not sure why it got bumped down to that next page because it still deals with the same stuff. So I'm just going to put this stuff up here. This one is saying, if you can read it, f of 2, capital F of 2 is 8. And then they want me to find what capital F of 5 is. So I want you to think about this logically for a second. If I'm talking about, so first of all, I'm looking at what numbers they're giving me here. 2 and 5 tells me we're talking about this interval from 2 to 5. If I find an integral, so if I say, here's my integral from 2 to 5, what that means is I'm going to have to find the actual integral of it, and then I'm going to plug in 5 first, and then I'm going to subtract what I get when I plug 2 in. Right? So this idea of having the integral with 2 plugged in, that's what this is. So I'm going to write it out like this. If I take the integral and I plug 5 into it, if I subtract the integral with 2 plugged into it, I will get whatever that integral was. And that value was a 6. They gave me that. Okay, the other thing they gave me, they told me that f of 2 was 8. So I could say, well, f of 5 minus 8 gives me 6, which means f of 5 is really 14, which is what they asked me for. So I just added 8 to both sides there and got 14.